Alright, in this last video, we're going to be looking at questions 11 and 12 of our test review. And for these two questions, you are allowed the use of a calculator. Question number 11, seniors start the school year in August with a motivation value of 250. If the value of their motivation depreciates 15% for each month of school, how long in months will it take for them to reach a motivation value less than half of what they started with? So we've got an exponential scenario here. We have this motivation value, and our initial value is, I got that number from another problem. Our initial value is 250, and we're going to multiply that times, typically we do 1 plus r, but since this value is depreciating, our rate is going to be negative, and we're going to do 1 minus 0.15 to the t power, and we want to know how long it takes for this value to be equal to 125, or half of the original value. So let's solve for t. First step, I'm going to divide both sides by 250. And so here on the left, 1 minus 0.15, I'm going to go ahead and change that to 0.85 to the t is equal to 1/2. So now I have an exponential equation, and to undo the exponential, I'm going to use a log. The base of my log needs to match the base of my equation. So log base 0.85 of 0.85 to the t is equal to log base 0.85 of 1/2. Here on the left, the log base 0.85 cancels out the base of my exponential, and I have t is equal to, you can type in this expression into your calculator, and we're going to get a value of 4.265 months. All right, let's move on to our last question, question number 12. An antique chair that was originally worth $45 in 1935 sold for $15,650 in 2010. Assuming that the increase in value of the chair is exponential, what was the approximate annual percent increase in the chair's value? Okay, so we have an exponential scenario here. Our original value is $45 times 1 plus r, and the rate here, the r, that's what we don't know, that's what we're looking for. And when the information that we're given here, if we subtract 1935 from 2010, we find that it took 75 years for the value of this chair to increase to $15,650. So now we need to solve for r. First step here is going to be to divide by that 45. And so over here on the left, so 1 plus r to the 75 power is equal to, and I'm going to go ahead and just keep this as it is. Let's put everything into the calculator at the last step to maintain our accuracy. So now I need to undo this exponent of 75. Notice this is not an exponential. I don't have a variable in the exponent. This is just a normal exponent. My variable's in the base. And so we don't need to use a log here. You could use a root. You could use the 75th root, but I'm going to take advantage of this opportunity to use a fraction exponent, 1 over 75. And we're going to do that on both sides. So here on the left, 75 times 1 over 75, those are going to cancel out, and I'm left with 1 plus r is equal to 15,650 over 45 to the 1 over 75 power. Last step, subtract this 1 from both sides, and r is equal to, and then at this point, get out your calculator and put all of this in at one time, and you'll get 0.0811, or we could write that as 8.11%. All right, part B of this question asks us to write an exponential function to model the value of the chair expressed in terms of the years since it was originally sold. So the value of this chair is equal to its original value, which is $45, times 1 plus that rate that we just figured out in the previous part, 0.0811, to the t power. And that would be our function model. Final part of this question: if the chair continues to appreciate at the same rate, in what year would you expect it to be worth $25,000? All right, so we're going to use that equation that we just wrote in the previous part. Our value is equal to 45 times 1.0811, if we add 1 and the rate together, raised to the t power, and we want this to be equal to $25,000. So first step, divide by 45, and I've got 1.0811 to the t power is equal to 25,000 over 45. So now I have an exponential equation. I need to undo the exponential, and I'm going to use a log. The log needs to have the same base as my exponential. So log base 1.0811 of 1.0811 to the t power, and then I'm going to use the same log on the other side. Log base 1.0811 of 25,000 divided by 45. So the log undoes the exponential here on the left, and t is equal to, and now we can go to the calculator and let's put all this in at one time, and we get that t is equal to 81.047 years. So that's how long it's going to take, but notice the question asked us in what year. So remember that our equation was representing the value of the chair since 1935. So we need to take our 81 years, I'm going to add that to 1935, and we get the year 2016. So in the year 2016, our chair would be worth $25,000.